Hi, everyone. I'm Jason Taylor. I'm a Microsoft MVP and a solution architect for particular software, which is the team behind NServiceBus. Building distributed systems can often feel complex, slow, and fragile. And so today, I'd like to show you how the right tools can actually remove this friction. So developing distributed system feels effortless, all the way from local dev to the cloud. Now, this is an interactive presentation. So if you can, scan this QR code or head over to slido.com and enter the code Effortless. We'll use it for a few polls, and you'll help shape the path we take through the demos. And while you're joining that, let's start by defining what we mean by a distributed system. So a distributed system is a system of multiple services or components working together, and they communicate over a network on different machines. So thinking servers, containers, or cloud resources. Here's a simple but common distributed system. We have a web front end, a API backend, and a database. Now, if your system looks small like this, or whether it grows into something larger and more complex, the same challenges show up. And these include orchestration, service discovery, reliability, configuration, observability, and deployment. And so the aim of effortless distributed systems is to address these challenges. So with effortless, it means shifting the focus back to what matters, right? Delivering features that users care about. We want to reduce wasted effort by eliminating manual setup, wiring, and boilerplate. We want to simplify the hard parts so teams can move faster and with greater confidence. Effortless, of course, doesn't mean no effort. It means reducing friction and spending effort in the right places. Now, to do that, of course, we need a solid foundation, and that's exactly where .NET Aspire comes in. So .NET Aspire simplifies distributed systems from the start. Now, I know you're asking, what is Aspire? Now, it's quite simply a framework. It gives us tools, templates, and packages for building distributed apps. At its core is a code-first app model, which acts as the single source of truth for services, resources, and how they connect together. It also provides pre-built integrations for common infrastructure like messaging, databases, caching, and hosting. And importantly, Aspire is designed to work end-to-end, from running locally during development all the way through to deployment in the cloud. That's enough slides. Let's see Aspire in action. We'll add Aspire to an existing app so you can see just how quickly we can begin to simplify distributed systems development. Over to my code. So I've got a very basic system for you tonight. There's the web UI, which is an ASP.NET Core Blazor server. There's a web API, which is ASP.NET Core Minimal API. That's the backend. Web UI is the front end. And we have this shared project, which has common types, which is shared between the backend and the front end. All right, I've already started the web UI, and so you can see it running. Now, you may have seen this before. This is the template that you get when you use a lot of ASP.NET Core projects, but I don't want you to worry. This isn't just a file new project. Yes, you've got your hello world. You've got your counter. You can count all the things you know and love. You also have a weather forecast, but I made it worse. This system is not as reliable as it used to be. Because remember, the fallacies of distributed computing. The network is reliable. That's the first fallacy. I didn't want you to think that we had a weather forecast that was going to return the weather every time. In fact, 30% of the time, this is going to fail. So we've got some problems there. But I don't want you to worry about that for now, because we've got a bug report as well. We can put in bug reports about this failing weather forecast and submit it. And sometimes that'll go through, and 30% of the time it'll fail. So we've got a little bit to work with here. And of course, the first thing we want to do with this app is to add .NET Aspire. And I'm using Visual Studio 2026. I thought I'd give it a spin. You can use JetBrains Writer or VS Code. We have first-class Aspire support in all of these IDEs. And if I want to add Aspire to these apps, it's quite simple. I'll start with the Web API, just right-click on that and go Add, and I can go .NET Aspire Orchestrator Support. If I come over here, it'll say, okay, we're going to add Aspire 9.5. Whoops. We'll also add 2 projects, the app host and service defaults. Great, let's do that. We'll do the same thing for web
Jason, excuse me interrupting there. Hi, Jason.
Yeah.
I'm afraid I think you're using a zoom tool to zoom in on that the screen there.
That's
I'm
right,
not sure
yes.
that's working with the streaming, unfortunately.
No
Could you
problem.
just give
I
it
won't
another
zoom.
quick try and see if it is that? Could you
Yeah,
just try
let's
zooming
try
in
it now.
again?
Okay.
Yeah, unfortunately, we're getting a black screen. So I wonder if you could just sort of, instead of being able to zoom too much, if you could just make sure you can describe what's going on so folks on smaller screens can follow along.
No problem. I appreciate
Brilliant.
that. Thanks, Matt.
Thank you. I'll just hide away now.
Thank you. All right, sorry about that, team. So I was right-clicking on the project, going Add, .NET Aspire Orchestrator Support, and what it did was it added this app host project and this service defaults project, okay? Now, if we look at the app host, it is that code-first model that's describing our distributed system. At the moment, it's just describing the 2 services, right? Web UI and Web API. But you can think of it as a place to describe all the parts of your system and how they connect together. So think APIs, databases, message brokers, anything else your system needs. We also have service defaults, which is just a simple class library. The code there. Just a simple class library that holds common configuration shared across all of our services. When we added Orchestrator support to Web UI and Web API, it actually also added references to service defaults, and they are now using these service defaults. So things like logging, health checks, telemetry, resilient HTTP clients, they've all come in. So let's run our app again. Now, the first thing you'll notice is that when it launches the Aspire dashboard. And this is really cool. When the dashboard launches, it's also launching the Web API and the Web UI. You didn't see this before, but of course I had to load those projects separately. But I don't have to juggle multiple projects anymore. The dashboard is going to load that up for us. You can see on the left-hand side here, we have resources. That's what you can see now. So it shows all the resources in our system. We can use this feature to inspect, to start, and to stop resources. So I can stop the API if I want and start it back up again. It's all good. We have the console. So instead of a bunch of console windows flying around that I have to manage, I can choose which one I'd look at. Here's my Web API console, my Web UI console, or this new feature in Aspire 9.5, or where it's got this nice little tag on the left-hand side, and I can see console output from lots of different processes. And of course, I've got structured logging, I've got traces and metrics, because we have a first-class open telemetry experience, which is really nice. Now, if I want to launch my app, I can just click on this link and it'll launch my app. I can still count all the things I love to count. I can go to my weather forecast, but something interesting's happened here. If I just keep pressing F5, every now and then there's a little glitch. And this one's a long one, but it recovered. So my weather forecast, which was unreliable before, is now reliable. Sometimes it's a little bit slow. And so you're probably wondering, well, what's happened here? Well, we can figure that out by looking at the Aspire dashboard. So if I go into traces, I can filter. I'm just going to type weather, and you can see all of the weather requests that we've made. And this one was kind of interesting, right? It's got all of these errors, 8.53 seconds. And I can look at this and I can have a read about all of this, and that's kind of interesting. I could dig in and figure out what's going on, but I don't have to, because I've got ChatGPT up here on the toolbar, and I can just click this button, investigate. It can do all the work for me, which is really cool. But then it spits out this great big wall of text. I'm not going to read that either. I'm going to say, tell it to me like I'm 4. I should get back down to my level. Easy summary for kids. You asked your app for the weather. The app tried to get the weather from another part. but it kept saying, uh-oh, something's wrong. You don't need to read the stuff in brackets, extra detail. The app didn't give up. It tried again and again and again. It tried 3 times. After a few tries, it finally worked and gave you the weather. The app had a little trouble, but it kept trying until it got it right. I love this. So easy to understand, even for a 4-year-old. So when we added orchestration support to our application, we got lots of things for free. And one of those was HTTP client resilience, and it was using Poly to retry that request whenever it failed. So that was really cool. So back to the solution. What I'd like to do now is just clean up a few things. In my web API project, I've got some chaos middleware enabled. We can go ahead and disable that now. We won't need it anymore. I'd also like to do a little bit of work with the app host. We've got health checks now that came in with service defaults, and I'd like the Aspire dashboard to know about them. So I can say with HTTP health check, and I can just specify the path to those health checks. And I'll do the same for Web UI. The other thing that I'd like to do is to make sure that Web UI doesn't start until Web API is ready. So what I'll do is I'll say, this is my Web API service, and I want Web UI to wait for the Web API, just like that. So it will not start until the Web API is up and running and it's healthy, because we've got the health checks wired in there. I also want to do service discovery, and we'll look at what service discovery is. But for now, if I say with reference Web API, that will go ahead and inject service discovery information from Web API into Web UI, which will make it easy for these two parts of the system to talk to each other. And by that, I mean I can get rid of some configuration that I previously had in Web UI. So I'm going to Web UI and program.cs. And you can see here, I've got a hard-coded magic string. Now, at some point, I was probably going to have to move that to app settings or some other configuration, but I can actually change it. I'll use service discovery to figure it out for me. So what we're saying here is that the base address of the Web API is HTTPS, or fall back to HTTP and go to Web API. And what's happening behind the scenes is service discovery is going to inject some environment variables for us, and it will use those. And we can see those in the dashboard now. So if I press F5 again, we've got that great local development experience. And I go to Web UI, I've started up, I can scroll down. We can see here, Web UI references Web API. We can see here the health checks for Web UI. And if we scroll past all our open telemetry stuff that we're now getting for free, we can see here's our URL for HTTP requests, and here's our URL for HTTPS requests. So we don't have to have those magic strings. Our services know how to talk to each other through service discovery, which is great. All right, back to our slides. So that's it. We've got Aspire running alongside our app, orchestrating the Web UI and the Web API as a single unit. No more juggling startup projects. With service defaults, we instantly get service discovery, health checks, resilience, and telemetry, all without manual setup. And the Aspire dashboard provides observability out of the box. We've got logs, traces, and metrics, so issues are visible, not mysterious, even for 4-year-olds. Next, we'll look at Aspire integrations. So Aspire ships with ready-made integrations, so you don't have to wire up everything by hand. These integrations cover the core services that every distributed system needs, whether it's databases and storage, messaging, caching, or observability. Aspire integration is just a ready-made building block that wires up common services for you, with health checks, telemetry, and smart defaults already included. As you can see from these examples, Aspire supports a wide range of integrations. And right now, our demo app is running on SQLite, but it's time to level that up. So let's swap it out using an Aspire integration, and I'll let you choose which database we go with. All right, so if you haven't already, scan that QR code or head over to slider.com and take a vote. Would you like to see Azure PostgreSQL or Azure SQL tonight? All right, here we go. The race is on. It's so exciting. Looks like Azure SQL is way out in front. It's exciting. But Postgres catching up. What have we got? 33 people voting so far, 34. That's a record for me. At the user groups I've been presenting this out, we got up to 30. Look at that. 51. Wow. All right. 54 for PostgreSQL. 55. It's taking the lead. Is it going to stay in front? We can go either way. This is effortless, right? It doesn't matter which path we choose. I'm going to let it go for a little bit longer just to give a few more people the chance to participate. And there'll be 2 more polls after this, so make sure you keep Slido up and running. All right. I think we have a winner. PostgreSQL. Let's go. So let's see how easy it is to wire up PostgreSQL using an Aspire integration. A little bit of cleanup here. Okay. So first, we want to describe the resource that's now going to become part of our distributed system, right? So we want to describe this PostgreSQL resource, and we're doing that in app host. Now, what I've done there is I've clicked on app host, and I've clicked add, and I'm going to click .NET Aspire package. That's essentially just going to load up manage NuGet packages, but it's going to specify the owner is Aspire. The tags are integration plus hosting. So we're getting .NET Aspire hosting integrations, which allow us to model the resources. I'll type Postgres just to filter it a little bit further. And I'm going to choose Aspire hosting Azure PostgreSQL. I'll install that. I accept. And now we can go in and model that resource. So I'm not going to type all this out because you'll get very bored with all my typos. But here it is. We're going to define a resource called a database server. It's going to be a Azure Postgres flexible server. I've named it SQL because I have no imagination. We use password authentication. And for local dev, we're going to run it as a container, and we're going to keep that container lifetime as persistent. That means it's not going to destroy and recreate the container every time the application starts or stops. So we should have a quick local development experience when PostgreSQL starts up. And it's going to do that using Docker on my machine, but you can use whatever tool you prefer. So if I was to run that now, it would load up PostgreSQL in a Docker container ready to use. But of course, we haven't really modeled anything, just that we have this resource. Let's now make it so that our web API is going to use that resource. But actually first, we'll just define a database. So using the database server, we can say database server.add database, and we won't call it that. We will call it Effortless DB. Okay, that's the name of our database and the connection name that we'll use with service discovery. Now, with web API, we can say, I want you to wait for the database to be ready. And I also want you to inject the service discovery information, okay? So web API is going to be dependent on the database. That means web API won't start until the database is ready. So the next thing I want to do is update the web API project. First things first, we'll strip out all of the SQLite stuff we had. So inside of program.cs, I was grabbing a connection string, and then I'm using Entity Framework Core. So I was wiring up an AppDB context using that connection string. We can delete that. We won't need that anymore. In app settings, I've got a connection string. We're not going to be using connection strings in app settings. We're going to use service discovery, so I'll delete those. I'll delete all the SQLite databases. And inside of WebUI CSproj, we'll delete the reference to the SQLite package. So just a quick cleanup of SQLite there. Next thing that I want to do is to add a .NET Aspire package, and we're going to add a .NET Aspire integration, but this time it's a client integration. So this is going to be how we will use Postgres within our web API. And client integrations come with lots of really cool helper code. They come with smart defaults. They wire up your telemetry for you, your health checks. The one we're going to use is Aspire Azure NPG SQL Entity Framework called PostgreSQL. So I'll go ahead and install that. I accept. And it's really easy to wire this up. All we have to do is say builder.add Azure NPG SQL DB context. We'll specify our app DB context, and we just need to specify the connection name, and that is Effortless DB, the one that I defined in app host, right? That's it. That's it. That's PostgreSQL wired up. So if I hit F5, we can see that Aspire will orchestrate these resources for us. It will start by launching the Postgres container. Once that's ready, it will create the database. Once that's done, it will start Web API. It's happening too fast. I made a mistake. That's okay. We'll fix that. And after Web API starts, of course, Web UI will start. Now, I've got some migrations that I created earlier. That's what's failed here today. We're using SQLite migrations now against a PostgreSQL database, which is obviously not going to work. So I'll go ahead and delete those ones, and we'll grab Postgres and paste that in. Done with that. Run it again. I put that in because it's a little bit faster than seeing me create migrations from the command line, right? So there we go. We've got a little bit of a warning there on Web API. We can just dive in and check what that is. Let's see. It's this line here. So it wanted to check what migrations the database was on, but the database had just been created. So there were no migrations available. For those of you who don't know, Entity Framework Core migrations are just a way to keep the database in sync with our data model. All right, so we're good to go. If we click on Web UI, go over to Bug Report, we should be able to submit our bug report, and that's ending up in our PostgreSQL database now. Not that anyone's going to look at it because this is a demo app, and we don't really have time for that. Okay, so that's it. With Aspire integrations, adding a database became effortless, right? We choose which database we want. We could have chosen SQL Server. We went with PostgreSQL. We could have gone MySQL, Oracle, what else? Cosmos DB. There were so many options. We choose what we want, Aspire handles the rest. The hosting integration provisions and orchestrates the database alongside our app, making sure it's ready before the Web API starts. And the client integration wired up Entity Framework Core with smart defaults and useful extensions. And thanks to service discovery, there are no more connection strings or other config headaches. All right. Now that we've seen Aspire in action, let's move on to messaging. We leverage messaging when services need to communicate reliably, at scale, and without tight coupling. Even though we have resilience in our application, if the Web API is not running, it can retry all it likes, but those messages are going to get lost. And of course, we don't want our bug requests, our bug reports to get lost. They're really important to us. So we need something a little bit more reliable. So I'm not here to teach you messaging, but I did want to cover the messaging essentials. So here's what makes messaging so powerful in distributed systems. Messaging ensures reliable communication between services. Messages don't get lost. They're delivered with durability and retries. It decouples services so that they can scale and evolve independently, and it gives us graceful failure handling. If something goes wrong, messages wait safely and can be retried until the system recovers. So in this simple example I've got here, you can see that service A will send a request and then moves on. The message gets added to a queue in the bus. When service B is ready, it takes the request, does the work, and replies back the same way. The queues are like inboxes, okay? So there's no waiting on live connections. Messages wait safely, and the system can retry if some sort of failure occurs. Now, this combination keeps our services decoupled and resilient. So now we're going to start with a simple demo. We'll add support for messaging using NServiceBus and the learning transport. I've chosen NServiceBus because I work for particular software, and that's the framework I know well. This is going to let us see how messaging fits into our app without worrying about infrastructure just yet, but we will get to that. That'll be the next demo. All right, so over here, let's do a little bit of a cleanup again. Stop it running. And what we're going to do is add in NServiceBus first. You can think of NServiceBus as the beating heart that keeps distributed systems running. And it works by sending messages between endpoints. Endpoints can send and receive messages, and messages are stored until they're ready to be processed. We've got a message already in shared, and under contracts, we've got this create bug request. Now, so that NServiceBus can recognize this message, we implement the interface and servicebus.iMessage. Now, there are a number of ways you can do this, including via convention. But this is the simplest way, so I thought I'd demonstrate that tonight. Now, with that in place, we've got a message. We need an endpoint, right? And so the first endpoint we'll create will be in Web UI. And to do that, first we'll install the relevant package. So we'll go manage NuGet packages, browse, and I'll type in NServiceBus extensions.hosting, which will allow us to wire up NServiceBus with the .NET generic host. I accept. Good. Now we're going to define our endpoint within program.cs in Web UI. So I'll load that up and we'll pop it in just here. Now this is a really simple endpoint. To create an endpoint in NServiceBus, we use an endpoint configuration and we give it a name. This one's Web UI endpoint. Now, for serialization, I've chosen JSON. I could have gone with XML, but JSON's named after me, so it seems like a good choice. And for my transport, how they're going to pass messages between endpoints, I'm using the learning transport. And that's essentially an option that we can use for local development or just demonstrations, really. It's just going to store these messages on disk until they're picked up by a service. So I have a message, I have an endpoint. Now we just need to use those two. So inside of my inside of my Blazor application, I have these components. And where is it? Where are my components gone? Isn't that interesting? Pages. Oh, it's in pages. Oh, I'm tired. It's a long day for me, but that's okay. I can keep going. I have more energy left. So this is our bug report page in Blazor server, right? And currently we're injecting an API and we will submit the request, the form, when it's filled out. And if it's successful, we'll show a happy message. And if it fails, we'll show a sad message. And it was failing 30% of the time with our chaos middleware. We're not going to use the API anymore. So instead, we're going to inject an NServiceBus service called message session, which is for performing simple messaging operations. And we'll call it message session. And we'll use it down here. But first, let's do a little bit of cleanup. So we won't need this or any of this. We're still going to show success because things will work. Get rid of that. We won't show any errors. There's not going to be any errors anymore. The system's going to be ultra reliable. Okay, so we'll say await message session.send. And where are we going to send it to? We're going to send it to the web API endpoint, which doesn't exist yet, but let's not let that stop us. And we will send it the request. What a mess. Should turn that off. Okay. Clean this up a little bit. There we go. Nice and simple. I think we're ready to go. All right. Yeah, let's launch it. F5. Okay, so the web API is starting. Web UI is starting. There we go. Jump into here. Submit a bug. We'll do test A. We'll do a couple of tests for this one. And that was successful. And test B, that was successful. Okay, so it's working, but the messages aren't going anywhere, right? Because we've only got one endpoint. So now we need to take some time to define the web API endpoint and also a handler to process those messages when it comes in. So let's go ahead and stop this and define the next endpoint. So we'll add the same package, right? So in Web UI, we added NServiceBus extensions hosting. Let's copy and paste like good developers, and we'll add that into Web API. Now we can use that in Web API program.cs to define our endpoint. The endpoint's exactly the same, except for the name. And that's important. If the two endpoints aren't using let me save that. If the two endpoints aren't using the same language to communicate, then they can't communicate. Get rid of that. Give it a second. It's looking right. I see what's happening. There we go. Good. Okay, there we go. So the only difference being the web API endpoint. We've got a little bit of duplication here, right? A little bit of friction. If only there was some place that we could store these defaults that we have for services. Maybe service defaults. We'll get to that. We'll get to that. We'll clean it up. But next I want to add the create bug request handler so we can handle the messages when they come in. So we'll put that inside of web API. We'll put it in a bugs folder and we'll call it create bug request.cs. And so you don't get bored, I'll paste in that block of code. We have a create bug request handler, and you can see it's implementing the interface I handle messages. So I like to think of it as I handle create bug requests. It implements this method from the interface, which basically takes the message, uses that to construct a bug, the bug entity, adds it to the bugs table, and saves the changes. Now, with that in place, we should be ready to start processing messages. Why don't I put a breakpoint on this just to make sure it's working, and we'll hit F5. Waiting. Web API is starting up. And look, we've hit a breakpoint already. So those messages that we submitted through Web UI, they were waiting there for the API to start up and pick them up, and now it's done it. So we've got our first message, test A, and our second message, test B. So that's working really well. So it doesn't matter whether Web API is running or not. These two services, at least in the context of bug requests, are now decoupled. If I was to take it a step further and separate weather forecast out, then we could completely decouple these services and they wouldn't be reliant on one another. All right, now I want to clean it up a little bit, right? Because we're going to move over to some real infrastructure soon. Maybe we'll choose Azure Service Bus or RabbitMQ. I don't know. It's going to be up to you. But before we do that, let's remove the duplication. And Aspire kind of sets us off on the right path with service defaults. So we can use that. So I'll stop this and do a little bit of a cleanup first. I'll remove NServiceBus extensions hosting from Web API, and I'll remove it from Web UI. We won't need to reference those packages there anymore. I will put it into, let me grab it, copy and paste. I will put it straight into service defaults, like that. And now we can go ahead and we'll add an extension method called add messaging endpoint to service defaults that we can use wherever we want to create a messaging endpoint that's going to have these default configuration. So inside of extensions is where all the magic happens. That's where OpenTelemetry is configured, health checks, resilience for HTTP clients, configuring OpenTelemetry. Actually, you know what? While we're here, let's just take a quick second to configure OpenTelemetry for NServiceBus. So we can go add meter NServiceBus.star. And we can also add the traces from NServiceBus. Add source, paste that in. There we go. And we'll keep scrolling down, find a blank spot for us to put our extension method. Okay, let me see. We'll paste that in. It's the same as what we had before. The only difference is that it's going to allow us to specify a name, and then it'll use that same configuration. A little bit of a namespace here that I got to remove because it brought it in by mistake. Endpoint configurations defined in multiple NuGet packages. And let's see, let's save. My save all shortcut's not working at the moment for some reason, but that's okay. We can roll with that. Don't panic. Okay, so now we can clean up Web UI and Web API to use this extension method, which will make our life much easier. So instead of all this, we'll grab that little bit of text and we'll say builder.add messaging endpoint, and the name is Web UI endpoint, and We don't need the comment anymore. The method describes it nicely, so we'll take that out. Then we'll go over to web API, program.cs, and we get rid of all this code, all that duplication, all that friction. Just make sure we name it the correct way, otherwise it won't work. There we go. So what do? We added an extension method to make it easier to add messaging endpoints of the same type. We're leveraging OpenTelemetry. So we've wired up OpenTelemetry with NServiceBus, which is good. It was already enabled because that was enabled when we added Aspire orchestration support. So that's it. We've added messaging using NServiceBus. It's already running locally with no extra setup. Because we're using Aspire, OpenTelemetry was already in place, so adding NServiceBus metrics and traces was trivial, as you saw. And we've been using the learning transport locally to help keep things simple, but it's not something we're going to deploy to production, right? So before we move on, let's decide together which message bus we'll use next. There we go. Let's find out. Is it going to be Azure Service Bus or RabbitMQ? I'm excited to see. Votes are coming in. It's like it's a landslide at the moment. RabbitMQ. Wow. I think we got 80 votes last time. Let's see if we can beat that. RabbitMQ is taking the lead. Azure Service Bus is creeping up a little bit though. Come on, Azure Service Bus fans. Let's see what we can do. 44 votes. 61. Looks, oh, Azure Service Bus is falling behind. All right. Landslide. Looks like we're going to be moving with RabbitMQ. I'll wait for a few more votes. It's close. Okay. Let's do it. RabbitMQ. Whoop. In the next demo, we'll switch from the learning transport to RabbitMQ. And we'll use an Aspire integration to do that. Okay. A little bit of cleanup here. Let's save everything. Do a quick build. Make sure that we're at least building before we move on. I do tend to make mistakes. So NServiceBus hides the details of message queues using a transport, right? Which connects it to a specific technology. Right now, you've seen the learning transport. Good for quick learning and testing, but not something that we're going to deploy. But thanks to this abstraction, this transport abstraction, teams can quickly change between transports. Now, you've chosen RabbitMQ today, so let's start by updating app host to include a messaging resource of type RabbitMQ. Now, you should know by now to do that, we're going to right-click, we're going to add a .NET Aspire package. So we're looking for a hosting integration for RabbitMQ. And this one is going to be Aspire hosting RabbitMQ install. And I accept. And then in app host, under apphost.cs, we'll define our messaging resource. So you can see we're calling builder.add RabbitMQ. We're naming our resource messaging, important for service discovery later on. We're going to use the management plugin because NServiceBus works with that to do various things. And we'll define the default port. This is the default port for the management plugin on RabbitMQ. And again, we'll keep the container lifetime persistent so we have a really nice local development experience that starts up quickly. Let's see. Now we want both the web API and the web UI to be dependent on that resource. So we'll say wait for messaging and with reference to messaging, and we'll copy and paste that, paste it on the web API. So now they're both dependent on it. And that means we can now, we've done all of our Aspire work, we can now switch over to updating the transport package. And we, thankfully, due to our refactoring, we only have to do that in one place now. So within service defaults. So I'm going to go ahead and install the NServiceBus RabbitMQ transport by clicking on Manage NuGet Packages, browsing, NServiceBus.RabbitMQ, install. And then I can go ahead and update the extension method, which we have down the bottom here. So instead of using this learning transport, we will get rid of that. Oh, you know what? I forgot one thing when we wired up OpenTelemetry. So let me fix that now. endpoint configuration dot enable open telemetry. I only have one place to do it in, so that's great. That's fixed for all endpoints, even though we only have two, but it's nice. Okay, so I want to wire up the RabbitMQ transport. So I've got a connection string thanks to service discovery. So I can just say builder.configuration.getConnectionString messaging, otherwise explode. And then I can wire up the transport, which is going to use that connection string. Oops, get rid of that. And then finally, I can use a feature of NServiceBus called enable installers, which will just automatically create the queues that I need within RabbitMQ. So that's it. Let's do a quick build. 5. All right, here we go. So messaging is starting up. That's using RabbitMQ. Once messaging starts up, Web API and Web UI will be able to start. First Web API, then Web UI. Give it a moment. Being patient. There we go. And localhost is up and running. Let's just make sure we can still submit our all-important bug reports. Test, submit. We hit the breakpoint, so it's flowing through very quickly using RabbitMQ in our local development environment, which is amazing. All right, so that's it. We switched from the learning transport to the RabbitMQ transport with minimal effort. With NServiceBus, it was just a small code change made in one place thanks to the refactoring we did in service defaults. The transport abstraction makes this effortless. We can use the same messaging code with any queuing technology like Azure Service Bus, RabbitMQ, Azure Storage Queues, or Amazon SQS. Using Aspire hosting integrations, we then added the new messaging resource, and Aspire handled orchestration and service discovery automatically. And the best part, of course, is our local development experience couldn't be simpler or better. One press of F5 launches the entire system ready to test and observe instantly. And that's an excellent F5, that's an excellent experience for a new developer who joins your team and is trying to get up and running. They press F5, then they start learning about the system. All right. So we've seen everything running locally, and now let's see what it takes to get it into the cloud. In this section, I'll show you how .NET Aspire and the Azure Developer CLI work together to make the code to cloud journey effortless. So .NET Aspire apps are flexible. The same app can run locally on your machine, in containers, or in the cloud. When you're ready to deploy, Aspire creates a deployment manifest, a blueprint that describes all the services and resources that your app needs. Now, of course, that deployment manifest is based on the the system that we described within App Host. So we can then use, with the deployment manifest, we can then use the Azure Developer CLI, or AZD for short, to provision those resources necessary to host our app and deploy it into Azure. And finally, with the same tool, AZD, we can configure a CI/CD pipeline so deployments can become automated and repeatable. Now, AZD is an example of one tool, right? But what Aspire has done is create a deployment manifest so that many tools can start to learn how to use this manifest and deploy your system wherever you need it to go. So you can use it, third parties can use it, it's ready to go. So AZD is an example, but AZD is certainly something that I know and love. So I'm excited to demonstrate it here tonight. So really, the only question is, which deployment pipeline should we use? Looks like I've got some votes in there already. So it looks like at this stage, it's going to be Azure pipelines, but keep those votes coming in. I'd love to see where we land. Look at that, 54 votes already, Azure pipelines. I've been doing a lot of GitHub Actions myself lately, but I've used Azure pipelines a lot in the past, so I know and love both of them. All right. Last chance. Last poll. You ready? 55%, 45%, 86 votes. I think that's it. Okay. Let's see it in action. We'll take our demo app using AZD. We'll set up a CI/CD with Azure pipelines. All right. There's a couple of things that I'd like to do to our app host before we move into using AZD. And the first thing is to enable external endpoints. So by default, these services, even though they have HTTP and HTTPS endpoints, they won't be exposed to the web. We need to actually say with external HTTP endpoints. So our web UI will expose its endpoints, but our web API will not. Just stop that. There we go. Okay. One other thing that I'd like to do is to include application insights. And that's quite easy to do. We can start by adding the .NET Aspire hosting integration. So I'll right-click on App Host, go Add, .NET Aspire package. Again, this is just NuGet Package Manager. So if you want, you can just come in to manage NuGet packages, or you can go .NET Add Package, however you like to add your packages. We'll go Install. And locally, I want to use the Aspire dashboard. It's great. But once I've deployed to production, I want something a little bit more production grade. So I'm going to use application insights for that. So I'll define this resource within my app host, and I will connect web UI and web API to that resource. But I only want to do it when I'm publishing, when I'm ready to deploy. So I can use code like this to do that. If builder.execution context is publish mode, then let's define an application insights resource, which is called insights. And we'll have a reference from web API and web UI to the insights resource. So we have service discovery. And that the only thing that's left to do is to actually enable application insights. And it's already there waiting for us in service defaults. We just have to uncomment some code. So if I scroll down here it is, and it's got the instructions on what we need to do. So first, if we want to enable it, we need to install this package. So we'll go ahead and do that. Manage NuGet packages on app host, searching for the Azure Monitor OpenTelemetry ASP.NET Core package, installing that. We come over here, we can uncomment this code, and we can delete that comment and just import the necessary namespace. So there we go. So now our app will use application insights once it's deployed to the cloud, as long as this application insights connection string is available, which will be managed by service discovery. So we don't have to do too much. Let's see. All right. So I talked a little bit about, let's save all of this and do a build, and we'll run it in the background just so that we make sure everything's fine before we deploy. It is not fine. That's okay. We'll figure it out. Let's do a build here. Let's check the package, Azure Monitor, OpenTelemetry, ASP.NET Core. I'm sure that's fine. Let's rebuild. Rebuild. That's good. F5. Give it a second. Yeah, we're fine. We're good. Okay, so we don't need this anymore. We're going to move to the command line now. So let's remove that. Let's have a look at that deployment manifest that I was talking about, right? There are a couple of ways that you can generate it. I'm just going to generate it using .NET Run. So you can see I'm using .NET Run. Project is the app host. So I'm in the solution directory at the moment. I'm going to choose Publisher Manifest, and I'm going to output it to the artifacts folder, which is also in the solution directory. So if I run that, it's going to generate the Aspire deployment manifest for me. Well, it was going to try. This happened to me earlier today. I'm not actually sure why it happened. So I did a build, and then I went up arrow, and this one. I'm just going to cross my fingers a little bit. There we go. That's what happened earlier. Haven't figured that out. Saw that this afternoon. Glad we could get it working. All right. So if we go into artifacts, and we look at what's being generated. So we've generated the Aspire manifest.json and a bunch of bicep. And I just wanted to show you the Aspire manifest. We're not really going to dig into it or anything like that, but this is the JSON file that is describing all of the different parts of our system based on our host, how they can be kind of hosted, and how they communicate with each other. Look at that. There's our app insights connection string that's going to come in there. So we're not really focused on that, but I did want to show you that. And the reason I want to show you that is because the tooling is going to use that. AZD is going to use that. So if we want to get started with AZD and the app that we've built, we need to make our app AZD compatible. To do that, we just run AZD init like that. And what it's going to do is ask us how we'd like to make this app compatible. Do we want to scan the current directory, and it will try and figure out what kind of app we have and how it should be hosted in Azure? Or do you want to select a template and kind of take a manual approach? Well, with Aspire and the deployment manifest, I really want to just scan the current directory and let it figure out for me, because this is the effortless approach. It says there's a limited mode warning. That's just because I haven't defined an Azure Container Apps resource in my app host. I could do that if I want to, but it's not necessary because it's a bit of a default anyway. So I confirm and continue initializing my app. It's asking me for an environment name. I'm going to call it Effortless Dev. And there we go. So our app is now AZD compatible. And what that means is there's an aspire.yaml file, an azure.yaml file, which describes our distributed systems and the services that are contained within and how they should be hosted. And there's also a next steps.markdown. I'm not going to go into those, but just know those two files are there, and the next steps.markdown is there for you to look at and learn how to use AZD and actually see what you can do with this app now that it's AZD compatible. You can see down the bottom here, there's lots of things I can do. I can run AZD up, which is a workflow which will package, provision using the deployment manifest. It will provision infrastructure in the cloud for me and deploy that application to the cloud. I can use AZD add to add new Azure components to my project. If I want to take full control of this process, I can use AZD infra gen to generate bicep to the disk that I can then modify to my heart's content. But I don't want to take that approach. There's friction in that approach if I have to manage the bicep myself. I want to go with app host, defining my distributed system, the code first model of my distributed system, as much as possible. Okay, and I'll use that as long as I can. So what I can do now, if we want to set up a CI/CD pipeline on Azure Pipeline using Azure DevOps, is run the AZD pipeline config command. Look, I've got some autocomplete there. So I've got provider, AZDO, so that's our Azure pipelines, and I've specified a principal name. We're going to call it Effortless Dev. Now, you should always specify a principal name because it's going to go to Azure and create a service principal for you, which will allow Azure pipelines, in this case, to connect securely to Azure and deploy the infrastructure in your application. If you don't give it a name, the name it will give it will be AZD. What is it? Let me see. It'll be AZD. Normally see the date and time. So AZD 2025 08. 10/08, and then the date and the timestamp, all numeric, and your cloud solution architect is going to hate you for it. So make sure that you specify the name. So we've called it SP Effortless Dev. Now, we haven't really done much other than run AZD edit and AZD pipeline config. And now it's going to ask us a bunch of questions. Which subscription do you want to use? I'll use this one. Going to retrieve the locations, and it's going to say, where do you want to host it? I'll host it in Australia East because that's where I am. You don't even have a pipeline. Do you want us to create a basic workflow for you for Azure pipelines? Yes, please. That would be great. Enter an Azure DevOps organization name, Jason Taylor Dev. That's my organization name. You don't have a Git repository. What are you doing? Should we create a Git repository for you? Yes, please. All right. It says, okay, we've created a Git repository for you. You've got a local Git repository now, but you don't actually have an Azure DevOps project. Should we go ahead and create that too? Yes. Create me an Azure DevOps project called Effortless. So it's going away and doing all of that for me now. And it's also going to go to Azure, create the service principal, configure the client credentials, because that's how it works with AZD and Azure pipelines. And then it's going to go to and establish, it'll go to Azure DevOps and establish that pipeline. It'll pass in all of the variables that it'll need. You'll see some of those be listed here in a moment. And then it's going to ask us if we'd like to kick off that pipeline, commit and push our changes and get it running. So we will say, yes. Would you like to commit and push your local changes and start the pipeline? Yes. There we go. So we can click on this link now. Just going down to the window over here. Bring it over here. And here it is. Here's our brand spanking new Azure DevOps Effortless project with its empty backlog, the repos with all the code checked in, a pipeline that's already kicked off and already busily deploying our application to Azure. So this is a starter pipeline, right? We can extend it and change it however we like. It's going to run through a number of steps, including installing AZD, which it will use in the pipeline, and setting up .NET. Then it's going to provision the infrastructure after it generates the Aspire deployment manifest. Then it will provision the infrastructure into Azure. Then it will deploy the application. Now that, of course, includes our web UI and our web API, but it also includes the Aspire dashboard that we've come to know and love. So we'll have access to the Aspire dashboard, which is great for us as developers. And then for our operations people, we'll also have application insights for those long-term insights into the health of our system and how it's running. We're not going to stick around and wait for this to finish, because if we do that, it will take a good 10 minutes. But we don't need to worry about that anymore. Now all we need to do is build features, commit our changes, push them through, and let the pipeline kick it off. All right, with Aspire, our C# app model became the source of truth. We didn't write any bicep or Terraform. The deployment manifest describes our entire system, and it feeds directly into tools like AZD, which is going to handle packaging, provisioning, and deployment. With application insights integrated, we have production-grade telemetry, and the Aspire dashboard we use locally is now running in the cloud. Using AZD pipeline config, we created a repo, generated and configured a CI/CD pipeline. We set up secure credentials to connect to Azure, all automatically, no steps required. And that's one of my favorite things, not having to do all of that setup, whether it's GitHub Actions or Azure Pipelines or something else. I love not having to do that. It's awesome. And because the pipeline's defined in code, of course, extending it for staging and production is straightforward. Well, that's all from me today. If you'd like to explore some of these ideas further, you can scan this QR code for 90 days of free access to the Distributed Systems Design Fundamentals course by particular software. I'm sure you'll enjoy it. I did. It's packed with 11 hours of practical hands-on content to help you level up your distributed systems journey. I'll leave that up for a moment. Okay. That's it. I hope you've enjoyed my talk today. The key takeaway is simple. Choose the right tools, remove the friction, and focus on what truly matters, delivering features that make an impact. Thank you.
Thanks, Jason. That was an excellent talk. We learned a lot about Aspire and messaging, and really tamed a lot of this, because there's a lot of moving parts, and you made it quite smooth for people to understand. So
yes, and I have to say, it doesn't always go that smoothly. There is friction in the demos, and sometimes when we're trying to use different integrations. But if you can find a path that works for you, it is that smooth. It's really cool.
Great. We have some questions from the audience. First off, will you be sharing this code somewhere?
I'm happy to share this code. Why don't I don't tend to tweet much anymore, but maybe I'll send out a message on Blue Sky, or I can share a link somewhere that you can provide if you like.
Yeah, that works. That works fine.
No problem.
So let's see, what else do we have here? Max asked if the deployment manifest is also usable for Kubernetes.
So Aspire does support deployment to Azure Container Apps, to App Service and Kubernetes, and I believe it leverages the deployment manifest, but you'll have to check with the Aspire team because I'm not 100% sure.
Okay. Got any questions, Mahal?
Yeah. First of all, the chat was loving. They were having their own conversations back and forth about it. Um, Now, I think the most recent question I see is the Aspire dashboard available in production after release? And I mean, I think initially it wasn't, but I don't know if that's changed at all.
Yeah, it has changed, and it's
Oh,
really cool. So yes, it has been deployed as part of that deployment that I did. When you're deploying to Azure Container Apps, it takes a little while to provision, say a couple of minutes. And then you just need to jump into that Azure Container Apps environment and give yourself permissions to that environment. Then you will be able to load up the Aspire dashboard. And it's actually really cool the way they've integrated it, because you can go to any of those services and click on Open Aspire dashboard, and it'll pop up and you can see those services running. You can check out all of the telemetry and figure out what's happening. And I think that's really cool for us as developers. But you saw, I also enabled application insights, because the telemetry in the Aspire dashboard's just in memory, right? It's just going to keep rolling over. So you need something kind of production grade as well.
Now, there was also, and you're right, that is fantastic. That view is I think, is the dashboard steals the show, right? It's really the
Yes.
star. Someone's asking, is the .NET team, Aspire team, talked anything about any large customers using it? I'm sure there's plenty of people using it out there, but have there been any, you know, some names we may recognize?
yeah,
Yeah,
case
that's a
studies,
great question.
whatever.
Yeah, actually, the Aspire team has a really cool channel on YouTube. I can't remember it off the top of my head, but I'm sure if you search it, you'll find it. And they've got like a 3 or 4 hour video where they're working with Bitwarden to Aspirefy the Bitwarden app. And so they do that live. So you can go and check that out. So yes, Bitwarden is one company that I can think of that's using Aspire.
Yeah, I think it's called Aspire Fridays, and I think somebody mentioned it in chat as well.
Yes,
So yeah.
yes,
That
that is
sounds
it.
right. Yeah.
Yes.
Yeah. Dean was asking, is that a GitHub icon in the top right of the Aspire dashboard? And what does that do then?
Oh, you know what? I think the icons. Oh, the GitHub icon. That's the Copilot icon. That's we had a conversation. Oh, there might have been a GitHub icon. Let me have a quick peek here. I don't have it running. Sorry, I'm off on my demo window again. So give me a second. Yes, so there is a GitHub icon there, and it's jumping straight over. Oh, you were sharing, good. And it's jumping straight over to the Aspire repo, right? So you can go there and raise your issues and ask your questions and have your discussions, that sort of thing. But I think the team works a lot on Discord as well, so you can check out their Discord channel.
Nice. Nice.
Now, have you had a chance yourself, Jason, to use Aspire for any projects?
Well, I'm in an interesting position at the moment because I work for particular software. So we're working on a product, we're working on a particular platform in NServiceBus, which I know and love. And so I'm hoping that as a result of this presentation, we will be able to start using Aspire with particulars, the particular platform. We actually have, and I can share it with you if you like, a Shape the Future issue on docs.particular.net. So if I fire that up and we go to, this is down here, Shape the Future, we're asking for feedback. So if you come here, NServiceBus and .NET Aspire, it's talking about what we've done. We've got a sample that shows you it running, and it actually brings up the whole particular platform using Aspire, which is cool. But you can come here, you can have a look at that sample, and you can tell us what's missing. So I'm not using Aspire yet, except for my personal projects. I'd love to be able to use it at work, and you can help make that a reality.
And I have to say, I don't know, Rachel, my favorite part was definitely those live polls,
Yes.
live feedback. Yeah. But
That's super
Jason,
fun.
what was your favorite part in doing this presentation?
My favorite part is the GitHub Copilot chat, because you can just click on one thing essentially, and then ignore everything that it gives you and say, tell it to me like a 4-year-old, and it really provides a nice, concise summary. So I enjoy that.
Yeah,
It's
it's
good.
great at summaries.
Now, if you give this talk a lot, is this normally the results of the polls? Are those common results that people ask, or is it just different all the time,
It keeps
depending on the
shifting.
audience?
Yeah, I've done Azure Service Bus. I've done all of the options now. So it's shifting, and it surprises me because I thought I would be able to predict what path would be taken. Of course, I had to prepare for all paths, so there's 8 different variations of this talk. But I thought I'd predict, and I can't. It's all over the place. I'd like to add some more options because there are plenty of options that I could add in, would be easy. But then I worry that in a month's time, if I run this again, I have to check all of those variations. And that could be tricky.
Yeah. So
Now, Syed asked, is it possible to integrate Aspire with client-side projects written in Angular?
Yes, for sure. Yeah, there's first-class support for Node.js, and you can check that out on the docs. So good question. Angular, React, whatever your flavor is.
Leonardo's asking, he has multiple start projects in the solution, one web API for each tenant with shared code between them. How do you configure Aspire for this case, one for each tenant?
Well, you can define app host in the way that suits your needs. Okay, so you could define it one for each tenant, or you could have perhaps some symbols or a little bit of configuration that it uses to load up a specific set of tenants or a specific set of services. Even it's really up to you to take control of that app host and to use it not just for publishing to the cloud, but also to control your development time experience. So you saw me using that builder.execution context. You can use that to make decisions on the fly for your local dev and for publishing.
Cool.
Now, somebody was asking, is there a way to get Terraform output instead of Bicep? I don't know if you covered that. I heard you mention a couple of those terms in the talk.
For sure. Aspire is primarily focused on Bicep at the moment, but the Azure Developer CLI supports both Bicep and Terraform. And that's really an interesting point, right? We can leverage the parts of Aspire that work well for us now, and we can use our normal processes for the parts that don't work so well for us. So for the parts that are actually causing friction. So if you're using Terraform and you'd prefer to do that, you can stick with your existing approach. Build your Terraform how you like to do it, build your CI/CD pipelines how you like to do it, or you could consider a tool like AZD that supports Terraform, and you could use the approach that I used tonight, or anything else really.
Federico and Simon were talking about, one of them started a question about storing the reliability logs and traces, telemetries. And you did talk about that a bit, but maybe you could just do a quick recap for us.
Yeah, no problem. So when we added .NET Aspire Orchestration, we got service defaults, and Web UI and Web API were both configured to use service defaults automatically just by clicking those buttons. And part of that was configuring OpenTelemetry. And so OpenTelemetry is a standard, and it can be used by any tool that supports OpenTelemetry. So we saw the Aspire dashboard, we saw application insights, but it's really up to you what you do with that information. So I used application insights and the OpenTelemetry package to send all of that data to the associated log analytics workspace, and it's going to be retained there for me for the long term.
Vlad was asking if he can customize resilience policies for concrete services, which I think we did get an answer in there, but just to double check.
There is the opportunity to do that. So within service defaults, you can jump into that code and change it however you like. So you could use the different HTTP clients with different resilience policies. That code really is your code, right? App host is a little bit special. It's an Aspire specific project, but service defaults is just a class library. So you're free to go in and change those defaults to be what you like to do, use it how you like to use it. So yeah, you're good to go.
And there's an interesting one here from Dean saying, are there any specific considerations when migrating an existing distributed system to Aspire?
That's a big topic, isn't it?
Yeah, I guess it's like, can you just take something and Aspirify it?
Well, you can. They do that on the Aspire Friday channel. But I guess it's all of our processes that surround that. Once we've done that, and once we've tested it, once we've passed it through to our development environment, once it's had those kind of sanity checks, and it's all of those processes that will indicate whether it works or not. Aspire does have great built-in support for testing. We saw in our local development environment, we were spinning up all these resources. Well, when we want to do integration testing, we can use Aspire to spin up those same resources and run tests against those resources. So it can certainly help to make sure that everything's running well, but ultimately it'll be all the processes that surround our deployment that will indicate whether it's going to be successful or not.
Now, I know we're almost time here, but let me ask one other question is, would you recommend that, if you're doing ASP.NET these days, that you do it with Aspire?
That's a really good question. I talked about distributed systems tonight, and we know that a distributed system is, two parts running on separate servers, communicating across a network. It's as simple as that. If you've got an app that communicates with a database across the network, it's a distributed system. I'd use Aspire even if it wasn't a distributed system, because I can fire up that dashboard, right? I can still fire up a local SQL Server resource. I can see all of that open telemetry. Like, there's value for using Aspire with almost any .NET app we build. So ASP.NET Core, yes, 100%. All of my ASP.NET Core apps I would use Aspire for.
Nice, thank you. Now, VS is great, but I'm going to throw a plug in for Writer. Writer's got great support for Aspire as well.
Yeah,
It's been on my list. I'm definitely going to fire up Writer and start learning all those resharper shortcuts again, because it's been too long and it's time to get productive.
Yeah.
Well, thanks again, Jason. It was an excellent talk, and
No worries.
we'll see you again soon.
Thanks for having me. It was wonderful. Bye.